Hello everyone. So let's see the analysis of inductors now. We have seen RC circuits, capacitor, RC circuits very deeply. Now we will study about inductors. We will not go that much into the inductors, but you will have a very clear idea about the inductors and you will be able to solve every interview and written test question. That's for sure. Okay. So let's start. So inductors. So like in the capacitor, what did we say? A capacitor, and it is initially having a voltage of V naught. Like in the same way in the inductor it is initially having a current of I naught. So what was the initial charge? That was C into V. What is the initial flux? That is Li naught, right? CV naught initial charge was there in case of capacitor. In case of inductor, the flux is Li naught. So we will be comparing. Okay, Q equals to CV, and phi equals to Li naught, right? Okay, and what is the initial current? That is already given. That is I naught. Okay, so initial flux is Li naught and initial current is I naught. Now, in case of capacitor, what we were doing, it was already having V naught voltage and we were forcing some current, and that current was increasing the voltage in the capacitor. Now, what we are doing, this inductor is initially having I naught voltage, I naught current. Now, let's assume we are forcing some voltage to the inductor. So, this inductor is initially having I naught current. Now, we are forcing the voltage. So, what it will do? This basic formula we have already seen, right? So, the voltage across the inductor VLT, no, not voltage, sorry, not voltage. Voltage across the inductor will be V only, right? When the switch is closed, the voltage across the inductor will be V only. Now, because of that voltage, it will develop some current. Okay, we were applying some current in the capacitor, so it was developing some voltage. Now we are applying some voltage across the inductor, so it will develop some current. So the current in the inductor, let's just call it ILT. So what will be your ILT? ILT initially will be I naught, and because of the applied voltage, it will develop some current, and that value will be V into dt, from minus infinity to infinity. Whenever the switch is closed, from there we will start. Like you remember V equals to L di by dt, right? From there you can derive the formula of I, that would be equals to 1 by L integration V dot dt, right? So what did you understand? When you force some voltage across the inductor, it will develop some current, right? And the value of this current is this. Okay, so when you force some voltage across inductor, it will develop the current. So are you able to connect? It will develop current. In case of capacitor, we were forcing some current, it was developing the voltage. Now we are forcing some voltage, it is developing some current. The first it was I naught, and in what direction? The voltage V is in this direction, no? The voltage V is in this direction. So the current will be from plus to minus. Voltage V is applied like this. So current will be from plus to minus. We will see more examples. It will be all more clear to you. Okay. But before that, let's see the property of inductors. What was the property of capacitor? It was charge storing element, right? Inductor is a flux storing element. There we applied charge conservation. Here we will apply flux conservation. Okay, it stores the flux, Li naught it stores, and the capacitor was storing CV naught. Are you getting it? And when there is a finite voltage across the inductor, that means not impulsive voltage. When there was finite current across the capacitor, what was happening? The voltage was remaining constant in short span of time. Like the voltage across the capacitor doesn't change instantaneously. In case of inductor, the current across the inductor doesn't change instantaneously. So when there is a finite voltage applied across the inductor, then IL T minus would be equals to IL T would be equals to IL T plus, but VLT minus would be not necessarily equal. Okay, it can be equal but not necessarily equal. Okay, I will write it in later on. Okay, so let's just, these are the properties. Okay, so here not necessarily equal. Spelling may be wrong, but yeah. So the current across the inductor does not change instantaneously. Instantaneously. But the voltage across the inductor can change instantaneously. Are you getting my point? Well and good. So now we will see the initial and final condition of the inductor. What was happening in case of capacitor? In case of capacitor, initially the capacitor was replaced with its initial voltage, and at steady state it was replaced with open circuit. In case of inductor, what will happen? Initially it is having I naught current, so I can make this current in parallel, right? This is a I naught current in parallel, and there is this inductor. So I just took out the current from the inductor, right? These nodes are A and B. So I just took out the current I naught from the inductor and just made a inductor L. Now this inductor L is having zero current. I just took out the current I naught, right? I just took out the current I naught, and now this inductor is having zero current initially at t equals to 0. So what will I do? At initial condition, what I will do? I will just replace it with open circuit. Okay, this is A, and this is B. Okay, so now the current is replaced with open circuit, and if there was no initial current, there was this initial current, so inductor was replaced with its initial current source. And if there was no initial current, what would have happened? You tell me. I hope you will be able to guess it right. Initially, how will we replace the inductor if there was no initial current? Zero current means open circuit, not short circuit. Zero voltage means short circuit. Zero voltage, that means short circuit. I also told this concept in while teaching about inductor capacitor as well. And zero current means open circuit, right? Zero current means open circuit. We have seen this concept before as well. So if there is no initial current, then it will be simply replaced with open circuit. So at t equals to 0, you will be replacing the inductor with open circuit, and at t equals to infinity, what you will be doing, that we will see. Okay, at initial condition. Now what do you mean by t equals to infinity? T equals to infinity means steady state of the inductor. At steady state of the inductor, what will happen? So what is changing in the inductor? Tell me, what is changing in the inductor? When we applied the voltage, the current was changing, the current was increasing. The voltage V was there, that was same, but the current was changing, the current was increasing. In case of capacitor, what was happening? When there was some current, the voltage was increasing. So now the current is increasing. Now till when the current will increase? Until the voltage becomes 0. Are you getting my point? When there is zero voltage across the inductor, here, if you put V equals to 0, the current will be the constant. The current will not increase furthermore. When there is zero voltage across the inductor, the current will not increase, because this V will go to 0, this only I naught will remain. So if there is zero voltage across the inductor will not develop further current, and the inductor has reached its maximum current. That means it will not develop more current, that is the maximum current, and that is what we call as steady state of the inductor. So at steady state, what is happening? The current across the inductor will be constant and the voltage across the inductor will be 0. In case of capacitor at steady state, what was happening? In case of capacitor at steady state, what was happening? The current was becoming 0, because if there is no further current, the capacitor will not charge. What is Vc? That is 1 by C integration I dot dt. If this is 0, the capacitor will not charge further, right? So in case of capacitor, what was happening? At steady state, the current was 0, so we replaced it with the open circuit. Now voltage is 0. 0 voltage means at steady state across inductor there will be 0 voltage. What is the meaning of 0 voltage? Tell me. Short circuit. That means at steady state inductor will be replaced by short circuit. Did you get my point? Okay. So at steady state we'll be replacing it with the short circuit. No matter how much current it is having, it will be having 0 voltage. So because of that, we will be replacing it with a short circuit. And what is the second analogy that you can see? What is voltage across the inductor? That is L dilt by dt. So at steady state, we have reached the maximum current, right? In case of capacitor, we have reached the maximum voltage at steady state. And now in case of inductor, we have reached the maximum current, right? So if IL is equals to max, that means dilt by dt would be equals to 0. That shows VL is equals to 0. Okay, just take your time and revise the complete concept. What did we see? Initially, the inductor is having some I node current, so we can replace it with the current source. If it was having no current, we would simply make it open circuit. At steady state, what we will do? We will simply, at steady state, what will happen? The voltage across the inductor will become 0 and it will not develop the current furthermore. If it is not developing the current furthermore, that means it has reached its maximum current. So now, because of 0 voltage, we can replace it with the short circuit. So there, in summary, at t equals to 0, what will happen? Inductor will be open circuited. At t equals to infinity, inductor will be shorted. It is opposite to that of capacitor, right? Opposite to that of capacitor. So what was happening in case of capacitor? Initially, the capacitor was being shorted and infinity it was open circuited. In case of inductor, what will happen? Initial 0 current, so that means it will be open circuited, and at steady state, it will develop current, developing, and it will reach its maximum value. So voltage will be constant. Sorry, voltage will be 0. So that means it will be shorted. Are you getting my point or not? Right? So let's see some questions. You have to write the equation of ILT. In the same way, we wrote the equation of VCT, right? And I was applying a current source. Now I am applying a voltage source, and you have to write the equation of ILT. So after t greater than 0, what will happen? This V voltage will come there. So how will you write the expression of ILT? ILT will be, now the V voltage is in this direction. So the current will be flowing like this, right? So I naught plus 1 by L integration V dot dt from 0 to some time t. We don't know the time. So it will be Vt by L. I naught plus Vt by L. Now what is happening? The voltage is developed in this direction. The voltage V is developed in this direction. So the current will be flowing in this direction. So what will be the expression of ILT? But the given ILT is in this direction. So 2 ampere current is set up already. 2 ampere current is set up in this direction only. Now because of the voltage, we will be having current in this direction. So 2 minus Vt by L. Are you getting my point? Or I should write 2 minus 1 by L integration V dot dt. Switch is being closed at t equals to 0 to some time t. So it would be 2 minus Vt by L ampere. And here as well, Vt by L ampere. Now for the next example, you will write on your own. You have to write ILT. So initially, where is the 2 ampere current? 2 ampere current is going upward, right? So minus. Now this voltage V, is developed here. So the current will be flowing in this direction only, right? Because of the voltage developed, the current is flowing in this direction. This 2 ampere is the initial current. You can't do anything with that. You just simply wrote minus 2 because it was flowing in the opposite direction. Now because of this V voltage, you are having current in downward direction, that is in the same direction of ILT. So what you will write? Minus 2 plus Vt by L ampere. What about this ILT? This ILT. Because of the voltage, this is the voltage. So because of the voltage, the current will be in this direction. So this 2 ampere current was also in opposite direction, and now because of this voltage also you are having the current in opposite direction. So simply the complete negative 2 plus, or for betterment I should write minus 2 current that was in opposite direction, and now one more current that will be also in opposite direction. So minus 2 minus Vt by L, or you can write minus 2 plus Vt by L ampere. Are you getting my point? I hope you understood. It is the same as the capacitor. It shouldn't be that much difficult, right? So let's solve our first order RL circuit. Okay, we are moving a bit quickly, not very quickly. Like I am teaching you every concept very neatly. So I don't need to teach you now what is first order circuit, what is zero order circuit. All this basic thing I don't need to teach you, because we have already seen it in RC circuit. What is first order circuit? What do you mean by first order circuit? What do you mean by zero order circuit? What do you mean by second order circuit? We have already seen it, right? So we have to solve what we need to find. We will find VRT, VLT, and IT, right? I will just write down the differential equation this time. Okay, I am not going to solve it, because solution I have already told you how to solve, right? So I will just write down the equation. What is the solution? You already know. Y of infinity plus y of 0 minus y of infinity e to the power minus t upon tau. Now what is the time constant? That also we will discuss here. So let's just write the differential equations. So first, for what we will write? We will write for IT. Okay, for IT we will write. So how we will write? V equals to IT into R. For IT I am writing, that means there will be no terms of VRT and VLT, only IT will be there. So IT into R plus L. What is the voltage across the inductor? That is L di by dt, right? What is the voltage across the inductor? That is L dit by dt, right? Now what you will write? You can write for VRT. So how will you write? V equals to VRT plus L di by dt you will write, but you need to express it in terms of VR, right? You need to express it in terms of VR. Yeah, so how will you express it? Let's see here. So V will be simply equals to VRT plus VLT. So what is VLT? VLT is L dit by dt, right? Now what is IT? That is VRT by R, right? IT is VRT by R, because VRT is IT into R, right? So IT is VRT by R, but that's it. So L d by dt VRT by R, that's it. Okay, or how you can write? You can just write L by R dVRT by dt. Are you getting my point? Now for what you will write? You will write for VLT. Okay, so let's just keep this time constant a bit downward. You will write for VLT now. So what you will do? V equals to VRT. How will you write VRT in terms of VLT? So from here only you can see VRT in terms of VLT. So from here we can see R by L integration. Okay, so what did we see here? We saw that VLT is L di by dt, and that is VRT by R. Right, so this is what we have seen. VLT is equals to L by R dy dt VRT. Right, so from here what do you see? VRT would be equals to R by L integration VLT dt. From a switch is being closed at t equals to 0, so from 0 to some time t, right? So V is equals to R by L from 0 to some time t VLT dt plus what? VLT, right? So these are the three equations in every term, right? In terms of VL you have written, in terms of VR you have written, right? And in terms of IL you have written. In any circuit you can write. If you just know the relation, you just need to apply a simple mathematics, right? I'm not mugging up anything here. I'm just writing the simple equation, that's it. Okay, and now you can solve this equation and get to your answer, right? Now you can solve this equation, solve these equations to get like this is not the complete equation actually. I should have written in differential form actually, right? So I should make a differentiation here, and if I make the differentiation of this will go to 0, and that would be equals to R by L VLT plus d VLT by dt. This is the differential equation actually. So you can solve this differential equation, okay? So you can solve this differential equation and get your final answer. So solve this differential equation, to get VRT, IT and VLT. Okay, and I have told you how to solve the differential equations already, right? Now what is the final answer of the differential equation? That we already know. Y of infinity plus y of 0 minus y of infinity e to the power minus t upon tau. So we will solve by that method. So there we need the time constant. So what is the time constant of a RC circuit? That is tau equals to RC. What is the time constant of a RL circuit? That I have already told. What is the time constant of the RL circuit? I told you one trick. Tau looks like a L, so it would be L effective by R equivalent. Tau is equals to L effective by R equivalent. Okay, so what is the time constant of this circuit? While finding the time constant, what do? We nullify the effect of input voltage or independent voltage source, right? So voltage source and current source actually. We nullify the effect of independent sources. So what are the independent sources here? Only a voltage source. So what will happen? One end of resistor R will come to ground, and one end of resistor R will be connected to inductor L. Okay, so time constant would be, what is L effective? That is L. What is R effective? R equivalent, that is R. So time constant of the circuit is L by R. Okay, so now let's solve the circuit. I haven't added page. So method 2. What is that method? Y of t is y of infinity plus y of 0 minus y of infinity, or 0 plus you can write, e to the power minus t upon tau ut, right? So given circuit, what is your given circuit? This is V, the switch is closed. You can replace this switch. If you replace this switch with a short circuit, what you will do here? You will replace it with VUT, right? So this is the circuit. First we can find IT, then we can find VRT, and then finally we can find VLT, right? So we will find all three together. At t equals to 0, what is happening? Tell me. At t equals to 0, inductor, what will happen to inductor? That will be open circuited. Capacitor is shorted, inductor will be open circuited. So at t equals to 0, inductor will be open circuited. So what will happen? This will be the circuit. Right? This is your VLT. This is your VRT. Not VRT, we should write. VR0 we should write. Right? VL0 we should write. VR0 we should write. And this is I0. And this is V voltage. VUT. Okay. So tell me, what is the value of VR0? 0 or 0 plus you can write. What is the value of VR0 plus? What is the value of VR0 plus? That is 0 volt. Because no current is flowing. Because I0 plus is 0 ampere. If the inductor is open circuited, so how much current is flowing? Inductor is open circuited, so 0 current is flowing. So IR0 is 0, VR0 is 0. What is the value of VL0? VL0 plus. That is equals to V. Instead of V, I should have used 5 volt. Okay. Otherwise, it will create problem. Someone will think I have written V here. Okay, I am using 5 volt here. Okay. So I will just write 5 volt. Okay. So initially VL0 plus is 5 volt. Now what will happen at t equals to infinity? At t equals to infinity, what will happen? The inductor will be shorted. Inductor will be shorted. So at t equals to infinity, this will purely be 5 volt. This is a resistor R. The inductor will be shorted. Why did I say purely be 5 volt? That means like this was our step input, but t equals to infinity will come somewhere here. So it will feel like a 5 volt here only, or you can write 5 ut as well, because 5 u of infinity is 1 only. So it will be 5 only. So that's why I have written like 5, purely 5. Okay. So inductor is shorted. So this will be your VL infinity. This is your VR infinity. And the current will be your I infinity. So tell me, what is the value of I infinity first? Inductor is shorted. So the current is 5 by R. What is the value of VR infinity? You should be able to tell these things, because we have studied the basics of network analysis. From here 0, from here 5. So it is 5 volt. What is the value of VL infinity? Since the complete inductor is shorted, so VL infinity will be 0 volt, right? So now let's just write the equations. So IT, from 0 to 5 by R it is rising. From 0 ampere to 5 by R. So it will be 5 by R 1 minus e to the power minus t upon tau. How did I write it? Y of infinity plus y of 0 minus y of infinity e to the power minus t upon tau ut. So if this is 0, so it would be y of infinity into 1 minus e to the power minus t upon tau. So we have seen immense example like this in RC circuit. So those who have studied RC circuits, only those people will study RL circuit from me. Okay. So first study RC circuit, then come to RL circuit. Okay. So this is IT. What about VRT? So initially VRT was also 0, and it is rising from 0 to 5 volt. So 5 into 1 minus e to the power minus t upon tau ut, right? And time constant being L by R. What is VLT? Initially it was 5 volt and going down to 0. 5 into e to the power minus t upon tau ut, and tau equals to L by R. Okay, we can make the graphs. and then we will practically understand the circuit, what is actually happening. Okay, so just take a pause, make the graphs, and then think what was actually happening in the circuit, because you have seen enough RC circuit and you have seen the practical way what is actually happening in those circuits. So now you can think of inductors as well, because you know what is developing the current in inductor. The current that is developing in the inductor is the voltage. So see what is initial voltage. Initial voltage is 5. So what would be happening? Some current would be coming, and because of the current, what is happening? That I will tell, but first you think on your own. Then I will tell. Okay. So let me make the graph, and till then you can think of the circuit. Okay. So these both are rising, right, from 0 to some value, and this one is decaying, right? Current is rising from 0 to 5 by R. The voltage is rising from 0 to 5 volt, and the current is decaying from 5 volt to 0. Tau is equals to L by R. Tau is equals to L by R. Tau is equals to L by R. Right? So now what is actually happening in the circuit? So for one circuit only I will write it down, and for other I will leave it up to you. So what is happening in the circuit? So let's just see at t equals to 0. At t equals to 0. 0 plus we can say. So here we have 5 volt. Inductor is open circuited. This is R. So what will happen? This 5 volt will come across inductor, right? 5 volt will come across inductor, and if there is voltage, what will happen? It will induce some current, or it will generate current in inductor. Let's assume at t equals to t1, the current through inductor is some ampere. The current through inductor is some ampere, we don't know. Let's just assume it is 1 ampere. Because of the voltage developed, the current is 1 ampere. So what is happening at t equals to t1? At t equals to t1, what is happening at t equals to t1? This is 5 volt, this is resistance R, and the current through the inductor is 1 ampere, right? Now it is not like that I am replacing it with this initial condition or nothing. Just an inductor that is having 1 ampere current, that means this resistance is also having 1 ampere current. Let's just assume the resistance value is 1 ohm. So how much drop will be there? Take R equals to 1 ohm. Take R equals to 1 ohm. Okay. So how much drop will be there? 1 volt. So what is the drop across the inductor? Now the drop across the inductor has reduced to 4 volt. Now the drop across the inductor has reduced to 4 volt. But what is the direction of 4 volt? What is the direction of 4 volt? This is the direction of 4 volt, right? The direction of 4 volt is this. So this 4 volt will also generate some current. This 4 volt will also generate some current, and the current will increase. So what are you seeing in the circuit? So slowly the voltage across the inductor is decreasing. Slowly the voltage across the inductor is decreasing, right? Is decreasing, and the voltage and the current through the inductor is increasing, and the current through the inductor is increasing, right? And when VL is equals to 0 volt, the current does not increase further. The current does not increase further. Just don't see it, okay? Think it, okay? Just don't watch it like a movie. You need to think it, okay? It's not a web series, right? The current does not increase further. Are you getting my point? What is happening? Initial inductor is open circuited, so 5 volt is there. This 5 volt is generating some current. Now because of this current, there is some drop across the resistor. Because of that drop, the final drop across the inductor is decreasing. So the voltage drop is decreasing, but the voltage drop is in the same direction only. So it will increase the current. In case of capacitor, what was happening? Initially the current was 5 by R. Slowly the current was decreasing, but the current was in same direction, so voltage was increasing. But the voltage was increasing slowly. Why so? Because the current was decreasing. If the current was decreasing, that means the speed of voltage increase was reduced. Here what is happening? Here the voltage is becoming low. The voltage across the inductor is becoming low. Still the current will rise. Current will rise. Why? Because the direction is this only. Still the current will rise, but slowly, not linearly. So that's why the graph is like this, not like this. Are you getting my point? The voltage across the inductor is slowly reducing because of the increase in current. If the current is increasing, that means there is a drop across the resistor, there is drop across the resistor, so final drop across the inductor is reducing. The drop across the resistor is reducing, but still the current will increase. Why the current will increase? Because the voltage drop is in the same direction. If the voltage drop was changed, then the current would flow in the opposite direction and the total current would have reduced. But the voltage drop is in the same direction, so the current will increase only, right? So because of that voltage drop, the current will increase only, but will increase slowly. Why it is increasing slowly? Because of the lower current. Sorry, because of the lower voltage. Are you able to grasp it or not? Look, if you are a gate aspirant, this is not really necessary, but if you go in the PSU interview or in just like some BARC or ISRO ISRO interview, so there if you tell these kind of concepts to them, they will be very, very impressed. Okay, because they know like gate aspirant don't study that much deeply. But why there is exponential? Like if they ask you why the current is exponential, everyone will say first order differential equation, that's why it is exponential. But if you tell them what is actually happening in the circuit, slowly the voltage across the inductor is reducing. Because of that, still the current will increase, but since the voltage is reducing, the current will increase, but it will increase slowly. So the graph doesn't go linear like this, it goes like this. If the voltage across the inductor was constant, the graph would have gone linear like this. Here I should have made the graph as well. Here I didn't make the graph. Actually the graph would go linear. So I guess I can make the graph here as well. I should have drawn it. Okay. So here what will be the graph of VLT? ILT, sorry. ILT. So initially I note current and then it is increasing. Linearly it is increasing. Why linearly increasing? With the slope of V by L. Right? Increasing, but increasing slowly. sorry, increasing, but increasing linearly. But in case of RL circuit, it was increasing slowly because the voltage across the inductor was getting changed, right? It will go on like this, right? And for these two, you will be able to make -2 to linearly increasing, and then this graph negative. Okay, well and good. So I hope you have understood the concept here. Okay, when VL is 0 volt, that means the current doesn't increase further, and that's the steady state. And that's the steady state. Well and good. Let's move on to the next circuit. Okay, so this is the same kind of circuit. In RC circuit, what did we see? First, we charged the inductor capacitor by V voltage, and then we connected a resistance. Now what we are doing? First, we are charging the inductor with some current. The current is 5 by R ampere. Okay, so to keep the calculation easier, I will take the value of R equals to 1 ohm. Okay, so what is happening for t less than 0? Because here I forgot to write, the switch is being closed at t, not t greater than 0, at t equals to 0, sorry. The switch is being closed at t equals to 0. Comment on ILT. Comment on ILT. Okay, so what is happening for t less than 0? For t less than 0, or for minus infinity to 0. For t less than 0, this switch is closed because it is opening at t equals to 0 and that is closing at t equals to 0. So for t less than 0, let's just call this switch as S1. No, let's just call this one as S2, this one as S1. So S1 is open and S2 is closed. S2 is closed and S1 is open because at t equals to 0 it is opening. So before t equals to 0 it is closed. So here we have 5 volt. Then we have a resistance R and inductor. Right? In case of capacitor, we were interested in capacitor voltage. Why so? Because capacitor has the property of storing its voltage. The voltage across the capacitor doesn't change instantaneously. In case of inductor, we will be interested in what? In case of inductor, we will be interested in the current. Right? In case of inductor, we will be interested in the current. Why so? This is ILT, so I will just write it IT. Why will be interested in current? Because the inductor has the property, that is, it doesn't change its current instantaneously. So we will be interested in current. So switch is closed for FWI. Switch is closed for minus infinity to t. That means that is very long time. Right? That means steady state would have reached. Right? Steady state would have reached. Right? So switch is closed for a very long time. That means steady state would have reached. So what would be the value of IT now? At steady state, what happens? I of 0. I can say what will be the value of I of 0 minus. At steady state, the inductor will be shorted. So the current would be 5 by R. Now what is happening for t greater than 0? For t greater than 0, what is happening? We can't comment on the inductor voltage, but we can comment on the inductor current. IL of 0 minus will be equals to IL of 0 will be equals to IL of 0 plus. That would be what? That would be 5 by R. Or we are taking R equals to 1 ohm. Here we are taking 1 ohm. So it would be 5 ampere. Right? This is 1 ohm. So it is 5 ampere. Okay. So this will be 5 ampere. Well and good. Well and good. Now this switch is S2 is open and S1 is closed. S2 is open and S1 is closed. So there is this inductor and then there is this resistance R. This is the inductor, this is the resistor. What we are calling as ILT, that is this, and what is VLT, that is this, right? So at t equals to 0 plus, the inductor is initially having a current of 5 ampere. So the inductor can be replaced with the current of 5 ampere and this is the resistance R, right? So that means the same current is flowing in this direction, that is 5 ampere. So this is your VLT, VL 0 plus actually. At t equals to 0 plus, this is having 5 ampere current, that means this 5 ampere current is flowing through the resistor R as well. So what will be VL 0 plus? That would be minus 5R, right? Because VL 0 plus is in this direction, right? This is VL 0 plus. VL 0 plus is in this direction. So that would be minus 5R. And what will be IL 0 plus? That would be minus 5 ampere. Why minus 5 ampere? Because initially the current is flowing in this direction. The current is flowing in this direction. 5 ampere current is flowing in this direction, right? So the current is minus 5 ampere. Okay. Now what will happen? Now tell me one thing. Now because of this 5 ampere current, there is this 5R voltage that is developed across the inductor. What is the direction? This minus 5R voltage will come across the inductor. This is a resistance R, this was inductor L. The current was 5 ampere in this direction, right? The current was 5 ampere in this direction. Now there is this 5R voltage that is developed, right? 5R voltage that is developed. The current was flowing in this, so 5R voltage is developed. So because of this 5R voltage, there will be some current developed, and the direction of that current would be this. Are you getting my point? 5 ampere current is flowing in this direction. Now because of this 5R voltage, there will be some current developed in the inductor and the direction of that current would be opposite. So this voltage, this 5R voltage will reduce the current. Till when the current will reduce? Till what time the current will reduce? The current will keep on reducing. Current will keep on reducing until what? Until, let's just call this as VLT. This was our VLT, na? Until VL goes to 0 volt. Until VL goes to 0 volt. If VL is 0 volt, so at steady state, VL is equals to 0 volt. So this is 0 volt. So what will be the current? What was the current? The current direction was this. So at steady state, VL infinity is 0 and IL infinity is also 0 ampere. Like what do they say? Like most of the students and most of the educator, what do they think? Initially it is having 5 ampere current. Initially the inductor is having 5 ampere current. At steady state, inductor will be open circuited, right? So if inductor is open circuited, so there is no voltage across the resistance, so current is also 0. Is this the correct concept? Your answer is right. What did I say? Initially 5 ampere current. At steady state, the inductor will be open circuited. This is what we studied. At steady state, inductor will be open circuited. So inductor will be open circuited. So the condition will be something like this, right? So inductor will be open circuited. So there is no current. So voltage is also 0 and current is also 0. You got the same expression. But is this what is happening in the circuit? At steady state, the inductor is losing all its current. Initially, it was having 5 ampere current. Because of this negative voltage, it is losing its current and eventually it is going to short circuit. Are you getting my point? In case of capacitor, what was happening? We saw the same circuit in case of capacitor as well. Initially, it was 5 volt. Sorry, at steady state, we replaced the inductor by short circuit only. So luckily, it has got correct. Sorry. At steady state, we replaced the inductor by short circuit only. So we are getting the same circuit. Okay, I'm really sorry for that mistake. So here we are getting the same circuit, but in case of capacitor, there was something different, right? What did we say? Initially we have 5 volt, okay, 5 volt, but this current was reducing. Sorry, because of this current, the voltage was reducing and eventually the voltage goes to 0 volt. So here the capacitor was also being shorted, not open circuited. Okay, at steady state, we have studied the capacitor is open circuited, but in this case, the voltage was continuously reducing. Eventually, it was going to 0 volt. So this capacitor was being replaced with the short circuit at steady state in this circuit, right? So here, if you go by the concept as well, like at steady state inductor will be short circuited. So this is what is actually happening in the circuit as well. But we have to be conceptually strong. What is the concept? Initially 5R voltage is there, so that is developing the current in the opposite direction. Because of that opposite direction, the current is being reduced. Slowly it will reduce and go down to 0. Are you getting my point? So here what did we see? In case of VL 0 plus, what was VL 0 plus? That was minus 5R. What was VL infinity? That was 0 volt. What was IL 0 plus? That was minus 5 ampere. And what was IL infinity? That was 0 ampere. So we can write down the expression of VLT. That would be minus 5R into e to the power minus t upon tau ut. What is the time constant? Just tell me. This we have written for t greater than 0. This we have written for t greater than 0. So what is the time constant? For t greater than 0, what is the circuit? This is inductor L. Forget about the initial condition when writing about the time constant, and this is resistance R. Right? The tau will be L by simply R. Okay. And what about ILT? ILT would be from 5 to 0, minus 5 e to the power minus t upon tau ut. What is the time constant? That is also L by R. We can make the graphs, right? Graph will be of same kind. VLT and ILT. Minus 5R to 0 it goes. And minus 5 to 0 it goes. Okay. And let's just solve this question by Laplace transform as well. Let's solve by Laplace transform. So if you remember, I have told you these concepts. So inductor will be replaced in Laplace transform. This inductor will be replaced with LS, right? this L will be replaced in Laplace transform by Ls. And if it is having an initial current, if the inductor is having some initial current I naught, how it will be replaced? With the battery of in the direction of current minus to plus. In the direction of current minus to plus. The direction of current is this. In the direction of current minus to plus L I naught. Make sure you don't write L I naught by S. It is L I naught because this is impulsive. In Laplace transform, if I am writing L I naught in time domain, what will I write? L I naught delta t. If in Laplace transform I am writing L I naught by S, what will I write in time domain? L I naught ut. So just make sure you don't write L I naught by S. It is L I naught only, right? And will be replaced with the this, or how we can do, the current is flowing I naught by S, so the inductor will be replaced with simply, here also I can make, or the current is I naught by S, and the inductor is Ls. So if you convert this voltage current source into voltage source, this will come only, right? In the direction of current minus to plus L into I naught Ls. So this we have already seen, right? This is nothing new here. This we have already seen, already taught. Right? This is already taught. Yeah. Yeah. So which circuit we have to solve? So at t equals to 0, at t equals to, for t greater than 0, what is the circuit? We already know, right? For t greater than 0, what is the circuit? We already know. Inductor L, resistance R, L and R, and initially it is having a current of 5 ampere, right? So this is the circuit. This is your, what is your VLT? VLT is this, and this is your IRT. ILT you can say, right? Now what will be the Laplace transform? So in the direction of current minus to plus, an inductor will be replaced with Ls. In the direction of current minus to plus 5L, Ls, and a resistance R. Right? What is the direction? That is this ILS. And what will be VLS? That will be here completely. That would be your VLS. Right? So actually the current would be flowing in this direction. From battery the current will leave from positive terminal. So we can apply the KVL. So 5L would be equals to KVL. You can apply the KVL. So minus of 5L would be equals to IS into Ls plus R. Is would be minus 5L upon Ls plus R. So it will be minus 5 upon S plus R by L. I of S. What would be I of T? IL of T. IL. IL. Why did I write minus? Because if the battery was opposite, the current would flow like this. But the battery is in this direction, so current is flowing like this. Right? So ILT would be minus 5 e to the power minus R by L into T ut. This is what we got. right? How did I write this? That I already know, right? 1 upon s plus a is, what is, e to the power minus at ut. So this is what I have written, right? So this is ILT. Now what about, this is the first one. What about VLS? What is VLS? Tell me. VLS is IS into LS minus 5L, right? From 0 minus 5L and IS into LS. IS is flowing in this direction. Actually, what is the expression of IS? IS is this minus. So IS is flowing in this direction, so it will give the drop like this. IS is flowing in this direction, so it will give the drop like this. So minus minus. So VLS would be minus of 5L into IS into LS. Are you getting my point? ILS is flowing in this direction. For us, ILS is flowing in this direction. So ILS into LS, this will give me drop plus 2 minus, like this, plus 2 minus, and this is 5L plus 2 minus. So what will be your VLS? Simple KCL KVL is there. VLS is minus sign 5L plus ILS into LS, right? So it would be, or there is simple way. What will be VLS? That would be ILS into R. No need to write. You can solve it by this as well. What will be VLS? VLS will simply be ILS into R. ILS into R. So it would be minus 5R upon S plus R by L. So it would be, what will be VLT? So VLT will simply be minus 5R e to the power minus R by L T ut. Are you getting my point? So that's how you can solve by Laplace as well, right? So if you are applying Laplace for two different domains, like first you can apply for t less than 0, then you can apply for t greater than 0. For t less than 0, we know that steady state will be already reached, and only the steady state part will be useful. So we didn't write for t less than 0. We are writing for t greater than 0 only. So steady state part is not that useful. So first we can solve by time domain, then here we can apply the Laplace transform. So, but you will prefer solving by time domain only, right? Because this is more intuitive, and you will be able to write the answer quickly as well. But in Laplace transform, you have to do some calculations, right? So this is this circuit. Okay, we can see more circuit. Let's just, before going to the, now I was thinking to go to the impulse voltage. Now I would have applied impulse voltage, but before that, let's just see one more circuit. Okay, we can see impulse voltage in next lecture or in this lecture only, but in the last. So let's just see one more circuit, simple circuit. Okay, so I can write down the question, then I can start the video. So this is the question. You have to comment on VLT and ILT. Okay. So initially, inductor is open circuited. What will be VLT? VLT would be 5 into R2 upon R1 plus R2. What will be ILT? ILT will be 0 only. Not ILT, I should have written. IL0 plus I should have written. IL0 plus. This is IL0 plus 0 ampere. At steady state, what is happening at steady state? Inductor is short circuited, right? At steady state, inductor will be shorted. So what will be VLT? VL infinity, sorry, that will be 0 volt. What will be IL infinity? IL infinity would be, inductor is shorted, so the current that will be flowing through the inductor would be, there would be no current through the R2, so the current through the inductor would be 5 by R1, right? You can write the current for IR, this I can call IRT. Okay, so here you can write IR as well. So initially inductor is open circuited, so IR is 5 upon R1 plus R2, and at infinity IL is IR is, sorry, IR, not IL, IR is 0 ampere, right? So I guess you can draw the graphs and everything. You can write down the equations as well. So I will just draw the graphs. Very easy question it was, just to, like, we have solved these kind of question in RC, so it seems very easy. Just see what is happening at t equals to 0, and now you can understand the circuit on your own. I will leave it up to you. Okay, try to understand it on your own by the concept that I have given before. Okay, so what is VLT? VLT initially, so it in case of VLT, it decreases from some value to 0, right? In case of IL, it increases from 0 to some value. This is for IL, and in case of IR, it decreases from 5 by R1 plus R2 to 0. This is VLT, this is ILT, and this is IRT. Okay, so this is the graphs. Okay, you can write down the equations, right? And yeah, what is the time constant? Tell me, what is the time constant? Here we can discuss about the time constant. What is the time constant? Input would be shorted. R1 parallel R2 and L. So it is first order circuit only, right? R1, R2 and L. What is the time constant? What is L equivalent? That is L. What is R equivalent? R1, R2 upon R1 plus R2. Right? So this is the time constant. Okay? Well and good. Let's move on to the next problem. There you will learn. Okay, I will just delete it later on. So here what you will learn. What happens when inductor is connected across a impulse input. Okay? So you will learn it here. Impulse voltage input. So shall I start like this, or shall I remove the inductor? I should remove the resistance for now. Okay, we will see two questions. First, now you know what is V naught already, so you just need to find I naught. In this question, you just need to find I naught. Okay, so tell me, what will be your I naught? I naught would be, what do you see here? Here, inductor is connected across infinite voltage, or impulse voltage, right? And while writing the property of inductor, what did we see? While writing the properties of inductor, there was an important point. What was that important point? Where is the property? There. What was the important point? There should be a finite voltage, and the voltage should not be impulsive. Now the voltage is impulsive, so this will not be valid. So current can change instantaneously. Current can change instantaneously. IL 0 minus is 0 ampere. Now this will not be equals to IL 0 plus. What will be the value of IL 0 plus? That we will see. So that will be I naught T. I naught T would be 1 by L integration Vt into dt, and I should have made the, okay, no need to do it because the impulse will come at t equals to 0 only. So from 0 to time t, so 1 by L Vs delta t from 0 to time t. Vs will come outside, so Vs by L. What is the integration from 0 to t delta t? That is ut. So this is your I naught t. So what is happening? IL or I naught I could have written. Okay, you would have understood, right? Here IL is equals to I naught only, right? I could have written IL or I could have written, to avoid the confusion, let me just make the correction. This would be IL, this would be also IL. Okay, what we are doing, lines are coming like this. Yeah, now it's fine. The current is changing here instantaneously. First it was 0 and suddenly it is Vs. There is one more way you can understand this. Now tell me, what is the unit of Vs? What is Vs? Voltage into time. What is voltage into time? Flux, right? EMF is voltage, right? EMF is a voltage only. Voltage, what is EMF? That is d phi by dt. So voltage into time is flux, right? So this Vs is a flux. So Vs is the flux here. Vs is the flux here. You are giving Vs amount of flux to the inductor, right? So what is flux is equals to Li. So Vs would be equals to LIL. So IL would be Vs by L. So what did you do? You just gave the Vs amount of flux in no time, and in no time the current is increased to Vs by L. What you were doing? You were giving I naught amount of current, I naught amount of charge in no time to the capacitor. So voltage was increasing from 0 to I naught by C. Here what you are doing? You are giving Vs amount of flux to the inductor in no time. So the current is increasing from 0 to Vs by L. Are you getting my point? Got it? Now we will solve the other circuit. Okay, let me make the circuit. Page 24. Okay, I will pause the video and make the circuit. Or I can directly make find VL and IL. VLT and ILT. The same circuit with the same input, just a resistance is there. So what should happen? You need to tell me. RL. In this case, why am I not making the switch? Because I know the impulse will come only at t equals to 0. That's why I am not making the switch. Right? So what is VLT? This is your VLT. And this is your ILT. Right? At t equals to 0. At t equals to 0. Inductor is having no current. Inductor will be open circuited. Inductor open circuited. This is your Vs delta t. This is your resistance R. Inductor is open circuited. So the complete voltage will come across the inductor. So this VL at t equals to 0 is Vs delta t. what is happening? Impulsive voltage is coming across inductor, and because of this impulsive voltage, what will happen? Sudden jump in current will be there. Current will be there, right? So at t equals to 0 plus, at t equals to 0 plus, what is happening? Input is V in is gone. Input is gone. So the input is shorted. At t equals to 0 plus, input is gone. So input is shorted, right? There is this resistance R connected. And now the inductor is having how much current? Tell me. Inductor is having how much current? Vs by L. Right? Vs by L because of this voltage. Right? So Vs by L ampere current it is having. Right? And this is your VLT. Right? So IL 0 plus is what? Vs by L ampere. Are you getting my point? Why? How did I write it? Previously derived. Previously derived. Because of the impulse voltage, how much current is coming? Vs by L. Now the same Vs by L current is flowing here. Now because of that Vs by L current, there is this voltage drop, right? That is Vr at t equals to 0 plus. Are you getting my point? Because of this Vs by L current is flowing through the inductor at t equals to 0 plus. The same current is flowing through the resistance as well, because they are connected in parallel, right? Now the same current is flowing through the resistor. So what will be the value of VL at t equals to 0 plus? That would be minus Vs by L into R, because VLT is negative of VRT. Let's just call this potential as VRT. So we can see here is VRT is negative of minus VL. VRT is the negative of, because 0 minus VRT is equals to VLT. So what is happening? This Vs by L current is flowing through the resistor. So VLT is 0 minus Vs by L into R. So it will be minus Vs by L into R. Okay. Now this negative develop will reduce the current. Now this negative voltage across the inductor, negative voltage will oppose the current and reduce it and reduce this. Are you getting what is happening in the circuit? And reduce it. What is happening? This is an inductor. Basically this inductor at t equals to 0 plus, this inductor was having some current that was Vs by L at t equals to 0 plus, but there is this negative voltage is developed across the inductor, that is Vs by L into R. So this negative voltage will develop some current in this direction, and that will reduce the Vs by L current. At steady state, at t equals to infinity, what will happen? At steady state, that means at t equals to infinity, what will happen? The current through the inductor will be 0. At steady state, when will the current, no, sorry, the voltage across the inductor will be 0, because at steady state, what do we know? Voltage across the inductor will be 0, right? So this is your circuit, because input is already gone. This is all R, and the inductor will be shorted, right? So even IR, whatever the direction was, IL, whatever the direction ILT, that would also be 0. So IL infinity would also be 0 ampere, right? So what was happening in case of ILT? ILT was initially it was 0, suddenly it was rising up to Vs by L, then it was going down to 0, right? This is the graph of Vs VLT. Not what is Vs? It is the graph of VLT, and then we will have a graph of VST. Sorry, ILT. So in case of ILT, what was happening? Initially it was 0, then suddenly it was rising up to Vs by L and then reducing to 0. Are you getting my point? Initially it was 0, then rising up to Vs by L, then reducing to 0. Rising up to Vs by L, then reducing to 0. Right? What was happening in case of inductor? Initially, in case of voltage, initially the impulse voltage come, then suddenly a negative voltage is coming, and then the voltage goes down to 0. Are you getting it? So I should make this axis a bit more longer, like this. So what is happening? Initially there is an impulse, right? Initially at t equals to 0 only, we are having an impulse, that is Vs delta t. Vs delta t. Because of this impulse, there was a sudden jump in the current, and the sudden jump was same in the resistance as well. Because of the negative drop of the resistance, we were having a drop of minus Vs by L into R, right? Here we saw that minus Vs by L into R, and then it decays down to 0. It decays down to 0. And what is the time constant? Time constant is, everyone can see, that is L by R. Here also the time constant is L by R. If you want to write down the equation of VLT, that is Vs delta t minus Vs by L into R e to the power minus t upon tau ut. And in case of ILT, from Vs by L to it decays down to 0. Okay. So this is by the time domain analysis. I will just repeat what did we do. Initially we saw that inductor will be open circuited, so complete voltage, impulse voltage will go there. Because of that impulse voltage, there will be and sudden jump in the current. The sudden jump is Vs by L. Because of that Vs by L, that same current is flowing through the resistor. So because of that, there is a negative voltage developed across the inductor, that is minus Vs by L into R. Because of that negative voltage, what is happening? There is an opposite current flowing in the resistor, flowing in the inductor. So it will keep on flowing until the current goes to 0. Okay, until the current goes to 0. It will keep on flowing until the current goes to 0. So it will be replaced with it should be, we can say it should be replaced with the open circuit, right? It will, the current in opposite direction will keep on flowing until the current goes to 0. So it will be replaced with open circuit. Here as well we can say this will be replaced with open circuit because the current is 0 ampere. So you can make it short circuit as well because the voltage is also 0 volt. So it depends on you if you say it is open circuit or short circuit. Okay. The opposite current will, here also the opposite current was flowing. So it will keep on flowing until the current goes to 0, or it will keep on flowing until the voltage across it goes to 0. You can say that. Okay. So here as well, it will keep on flowing until the current across it goes to 0. So current is also 0 and voltage is also 0. Okay. So that's how the graph goes. And now if you can't understand this time domain analysis, you can solve it by Laplace transform as well. Okay. Solving by Laplace. Okay. But in the interviews, this time domain analysis will be expected. Okay. So let's just solve by Laplace. And slowly IITs will also start asking questions nicely, right? So this is Vs delta t, so this would be replaced with Vs only, right? Vs delta t is replaced with Vs in Laplace, right? So what is your Is? Is would be R plus Ls. Actually, this should be your VLS. So Is would be Vs by R plus Ls. So what would be your IL of t? IL, 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 IL of t. That would be Vs by R e to the power minus t upon e to the power minus this. Oh, sorry. Let's just write one more step. ILS would be L will come outside. So Vs by L upon S plus R by L. So ILT would be Vs by L e to the power minus R by L into T ut. So this would be ILT. Okay. What about VLS? VLS is ILS into LS, right? So Vs into Ls upon R plus Ls, right? So you have to break it down actually. Yeah, we have to break it down. So how will we break it down? I can do something like this: R plus Ls minus R upon R plus Ls. Vs 1 minus 1 upon S plus L by R, right? From where we are getting VLT is Vs delta T, because this is simply Vs, minus Vs e to the power minus, it would not be L by R, it would be R by L. Okay, simple mathematics it is there. So this R will come outside actually, sorry, L will come outside, so it would become, at upper side it will become R by L, at upper side it would become R by L upon S plus R by L. So Vs into R by L, Vs into R by L, right? This is what we are getting, Vs into R by L e to the power minus R by L into T ut. This is the expression of VLT. I hope you are very much comfortable with all those concepts. Okay, because we have solved many circuits. So I hope you guys are able to understand these circuits quickly. What was happening initially? The complete impulse voltage was coming. Because of that, there was a sudden jump in the current. The sudden jump in the current were inducing some negative voltage. Because of the negative voltage, the current was reducing. So eventually, the current was going down to 0. Also, the voltage was going down to 0. Okay. So this was happening in the circuit. So here we saw the pulse in this impulse input as well. Then we saw these simple examples as well. Okay. We solved the question by Laplace transform as well. We solved the question with the simple time domain approach as well. So I hope you are understanding the concept and you are actually enjoying the lectures now, right? In RC circuits, we also went to this depth, and in RL circuit also, whatever that is necessary, that we are seeing. We will solve many questions on RL circuit, because in written test, they will ask many questions from RL circuit. In the interview and in the exam, like I have seen many questions in RC circuit, but in the written test or in the gate exam, there can be questions from RL circuit as well. Okay. So we will solve many questions in RL circuit, but these many concepts are there. These kind of concepts are there. So I hope I am not going to miss any concept that is necessary for the exam. Okay. So yeah. So now we will see these three circuits. That would be the last circuits we will be seeing. And after that, there is some concept that I need to tell, like some important concepts, like this is the second order circuit, how this is a second order circuit. So this concept, then I will tell the concept of transfer function, poles and zeros, because these are necessary for network analysis as well and for analog electronics as well. Although we studied it in control systems, but these are necessary for these two subjects as well, for network and control, for network and analog. So I will tell the basics here. Then we will see examples, like we will understand what is pole, what is zero. So these basics we will understand. Okay. So by that our theory part will be completed. So I hope in the next lecture our theory part will be completed. Then we will move on to the questions only. Okay. Thank you.